Hi, in this tutorial we have an exercise related to reaction mechanism. The question in the exercise asks us, show the reaction mechanism of the following reactions using curved arrows. Let's start from the first option. In the first option, let's look at what is happening first. We have here a carboxylic acid, and in the product, this carboxylic acid is losing its proton or hydrogen. So basically, this hydrogen is lost, and the bond between oxygen and hydrogen is breaking. And where is this hydrogen moving? It's moving to this oxygen. So basically, the bond between oxygen and hydrogen breaking, and there will be a new bond formation between this oxygen and hydrogen. Okay, so uh, when we check also this oxygen, it has two lone pairs now. In the product, it has three lone pairs. Basically, when this bond breaks, we have to use this sigma bond or single bond as a lone pair. And also, this oxygen has three lone pairs, and in the product, it has two lone pairs. One lone pair is used to make bonding with this hydrogen. So after summarizing these things, we can easily write the reaction mechanism. Okay, so first, what we have to show, we have to show an arrow from oxygen to the hydrogen, meaning that there will be a bond formation between this oxygen and the hydrogen. And I have to start from the lone pair of oxygen. Then the bond between oxygen and hydrogen should be broken, and the bond should be used as the third lone pair. By adding these two arrows, we were able to show the reaction mechanism for the first reaction. Let's move to the second reaction. In the second reaction, we have two reactants, one product. So basically, this is an addition reaction. And what is happening? A new bond between this oxygen, this oxygen, this oxygen, and this carbon is forming. If you check the product, there's a new carbon-oxygen bond formation. So that's the first thing. Second thing, if you check this pi bond, it's not anymore here in the product. What's happening? There is now a single bond, sigma bond, and oxygen has three lone pairs instead of two lone pairs. That's right here. So what's gonna happen? We can summarize. A new bond between this oxygen and this carbon will be formed by using the lone pair of this oxygen, and then this pi bond will be broken, and we will form a sigma bond here just, and the oxygen should have three lone pairs. So after summarizing these things, now let's just write the reaction mechanism. So a new bond between oxygen and a carbon is forming. So a curved arrow from oxygen to carbon. Let's draw it better. Forming. I have to use the lone pair of oxygen, and I have to end on the carbon that is connecting these two atoms. Then the pi bond is breaking and it's moving as a lone pair on oxygen. So by just showing these two arrows, we show the reaction mechanism. In the third example, it is exactly the opposite reaction. We have one reactant, but we have two products. Basically, this is an elimination reaction. What is happening? Let's summarize. Here we have just a sigma bond. It's forming a pi bond. How can this pi bond be formed? We have to use this lone pair to make pi bond. Then the bond between carbon and oxygen, this bond is breaking and this methoxy anion is leaving. So after summarizing these things in the reaction, we can easily write the reaction mechanism to justify these findings. So we have to form a pi bond here, and a bond is breaking because now we will have 5 bonds around carbon. It's not possible according to octet rule. So one bond should be broken, and it's broken, we can see. So carbon-oxygen bond is breaking, and the bonding electrons in between carbon and oxygen is moving on oxygen as another lone pair, and we are forming methoxy. Now let's come to the fourth exercise, fourth option. It's a substitution reaction basically. What is happening? OH is substituting the iodine here. So it's a displacement reaction basically. What is happening if we check the product here? OH, especially the oxygen, will be connected. This oxygen will be connected to this carbon. Yes, here they are connected, and the bond between carbon and iodine is breaking, and iodine left the molecule. So after finding these clues, we can easily write the reaction mechanism. So first of all, by using the lone pair, one of the lone pair electrons of oxygen, we have to create a single bond, a sigma bond between oxygen and carbon using one of the lone pair electrons of oxygen. Then we have to break also the bond between iodine and carbon, and this bond should be broken. And if we check here, iodine is having fourth lone pair. It has here 4 lone pair electrons. So the fourth pair is coming from this bonding electrons. So basically adding 2 arrows explain the reaction mechanism. Now let's look at the last option. The last option here, we have a hydroxide ion, and it's turning into water molecule. Hydroxide is turning into water molecule, meaning that it is gaining a hydrogen. That's the first thing. Second thing, the chlorine here is connected to carbon, and it's not anymore connected, so this bond should be broken. And there's another observation. There should be a bond formation, a pi bond formation between carbon and carbon. So there should be a pi bond formation. Okay, so now let's try to write the reaction mechanism. So let's erase these things. Okay, so we can understand that this hydrogen should be connected to this oxygen. So I have to use the lone pair electrons of oxygen, and oxygen and hydrogen is connected. Then this bond should be broken, but there should be a double bond formation between this carbon and that carbon. So the electrons between hydrogen and carbon should move as a pi bond here between carbon and carbon, so that we can form a pi bond. But at the same time, the bond between carbon and chlorine should be broken, and chlorine should obtain, and a fourth lone pair should be on chlorine, which is the case here. Now we have added 3 curved arrows to explain the reaction mechanism for this reaction, particular reaction. Thank you so much for watching the video.